For my outside scan, I scanned these pipes outside of ESJ. In order to process this data, once again, I used the row and RPC values that we calculated in homework 6, and then ran the datageneration.py script, which loaded in all of the JPEG files that I created and applied the mask in the same as the last video. Here we can see that there's quite a bit more noise applied to these images. There was a lot more light out by the pipes that I scanned compared to being in my apartment, which meant that I had to edit the mask in order to get proper data to come out of this. After inputting all of these images, I then got the output here of these pipes. We can see that there are clearly two pipes going up there and the base at the bottom, which is flat. We can even note one of the posters, seen right here in the picture, that I called out in the image as a place where we might get some fun artifacts.
After turning each of those scans into a point cloud, it's time to head to MATLAB. To plot a point cloud, you want to use the function pointCloud to read in that text file into X, Y, and Z data. I then chose to rotate and translate my different point clouds around, and I'll show you the process of how I did that shortly. Here we can see that I've plotted 4 of my scans, and I've aligned all of those already, but I'm going to walk you through the process of aligning my 5th scan. So here are the 4 scans that I've already aligned. You can see that the 2 pipes are very clear here. On this 5th scan, the last pipe is still clear, but it's far away. To move it, the first thing that I do is 0 the new pipe. We can see the position in the y-axis, the position in the x-axis, and the position of the z-axis. So I'm going to move that up to 0 to match the other pipes. I do that right here using the rigid transform 3D function, which I can now run again. And now that that's loaded, we can see that the pipes are now overlapping each other. I'm then going to rotate this cyan pipe, once again using the rigid transform 3D function. Until we can see that the pipes are now facing in the same direction, but there's still some small offset that I need to correct for because this pipe is supposed to be over here. So I'm going to translate it one last time just to move it right into position. All of the values that I found for these translations and rotations were gathered experimentally by making small tweaks and then moving it through about 5 attempts, I would say, until I got it just right. And there we can see the final point cloud collected. To combine all these point clouds, I used the PC merge function to combine my point clouds 1 and 2, and then to combine point cloud 5 into that, where I then plot it here. After saving that point cloud to a file, I'm opening it in a program called Cloud Compare, which is great at manipulating point clouds. So I'm going to open my points.py file and apply all of this, and here you can see my point cloud. I have quite a few points that are outside of where we actually want the image to be, so I'm going to erase all of those. The way that you do that is by selecting your point cloud on the top left, and then going to this scissor icon, and then you can draw shapes around the points that you'd like to get rid of. Once I press the right-click button, it finalizes it, and I can go here in the top right to remove those points. Once I finish with the tool, it will separate that into the remaining points that I got rid of and the segmented points that I want to keep. I'm going to keep doing this, and I'll show you what it looks like once I'm done. I've now finished segmenting the mesh, and so I'm going to press the check mark button again and delete the remaining points. Now we can see my final finished point cloud that I can save to any point cloud format that I'd like, including .text or .py. Thank you for watching.